Hello, in this video I'll be talking about rate of change in slope. The definition of rate of change is right here. It shows the relationship between two changing quantities. So when one quantity depends on another, the following is true. The rate of change equals the change in the dependent variable over the change in the independent variable. Well, what does that mean? That doesn't mean a whole lot until we put it into context. So over here I have a T-chart that shows the distance marched by a marching band in relation to minutes. So this quantity, distance, depends on how much time they are marching for. So instead of writing change in the dependent variable, in this case, change in the distance over change in time. So to find the rate of change, we can pick one of these ordered pairs, which you'll probably remember from last chapter. We often call the independent variable x and the dependent variable y. And you can think of these as like ordered pairs here. But if we show the change in distance from one pair to another, so like 260 to 520, so the change in distance there is 520 minus 260 over the change in time, which is 2 minutes from 1 minute. So basically what that's saying is the rate of change is that the band is going to travel 260 feet in 1 minute. And you can do that for any number of these points here. So 780 minus 520 over 3 minus 2. So 780 minus 520 over 3 minus 2 would equal 260 over 1. And you can even, let me shrink these down for a minute. You can even pick ones that are not right next to each other. So if I wanted to see the change in time based on a distance change of like 1040 to 520, we could do 1040 minus 520 over 4 minus 2. And we're going to get 520 over 2, which reduces to 260 over 1. Now when you have a relationship like this where the rate of change is the same each minute, so every single minute the marching band moves 260 feet, that's going to be a linear relationship. So the picture of that on a graph is going to look like a line, which I'll show you on the next page. So I've taken that same T-chart there and I've plotted these points, so 1 comma 260, so time of 1 minute 260, time of 2 minutes 520, and so on. And I've made these dots, and I'm going to connect the dots with a line here. Alright, and they should connect in a pretty straight line, which they do. And so this shows the linear relationship in the picture that I was talking about. And here was the formula that we used. Remember, rate of change was equal to the change in distance over change in time. And mathematically, we call that a slope. So rather than call it the rate of change every time when we're working on a graph of a problem, we call it the slope, which is the vertical change, how high the point is from one point to the next point, over the horizontal change, which is the left-right movement. And we call that rise over run. So we'll see how that applies. So here we have a graph of a different linear function than the one we had before, and we're going to see if we can find the slope based on the rise and the run of this. So we could pick any 2 points. Obviously we wouldn't want to pick a point like here because we don't know what its coordinates are. But if we pick something on an intersecting grid line here, like here, we know its coordinates are -4 comma -3, and I could write that down. And now I can see that I'll just pick another point here where there's 2 coordinates coming together. I could choose this one, which is -1, -1, or this one here, which is 2 comma 1. Let's go to the close one for now. So the rise here, we have to go up 2 grid lines to get to this point. So that's a rise of 2. And then we have to go over 3 grid lines to get to this point. So that's a run of 3. So rise over run is going to equal 2 over 3 in this case. Now if we would have chosen this point and this point instead, then we would have to go up 1, 2, 3, 4 to get up to that grid line, and then over 1, 2, 3, 4, 5, 6 to get to that grid line. Well, incidentally, 4 over 6 is equal to 2 over 3. So no matter what 2 points you choose on a graph to figure out the slope, you'll get the same slope each time, which is 2/3 in this case. Let's try it again on this graph. So on this graph, I pick a point here, and then we could pick another point right here. And it looks like we have to go down 1, 2, 3, 4 grid lines, which is a rise of -4. Since we're going down, since we're not rising at all, we're going down, it's a negative. And we're going to go right 1, 2, 3, 4, 5. And so the slope in this case, which is rise over run, equals -4 over 5. So we can have a negative slope as well. Which leads us to this equation here, the slope formula. Slope equals rise over run, like I said, and then we have this y2 minus y1 over x2 minus x1. Well, what does that mean? y2 minus y1 over x2 minus x1. Well, let's find out. So I'm going to go back to one of these previous examples we have, and I have this formula written out here. And so I'm going to pick 2 points. So this -4, -3, and then I'll just pick this one here. It doesn't matter which 2 points we pick, so 2, 1 will work. Now, these are not exponents. They're small numbers, but they're below the letter instead of above. So above would mean an exponent, below is called a subscript, and that's just a way of differentiating between the two things, because we have two xy coordinates here. So we can't just call them xy anymore because you won't know which one I'm talking about. Okay, so we can call this one x2 and y2, and this one we could call x1 and y1. And it doesn't matter, again, which coordinates are the 2 and which coordinates are the 1. It's just a way of showing that they're different. So the y2 in this case is a 1 from here. The y1 is from here. This is the -3. So remember, the y2 minus y1 over x2, which is 2 in this case, minus x1, which was -4. And so the slope is going to be 1 minus -3 is 4, and then 2 minus -4 is 6, and so 4/6, which would reduce to 2/3. So that's how you would do it using the formula. Let's do it again on this one. So I wrote out the formula again for us. If I can expand it, there we go. And so we're just going to plug in values. So we can choose this point here, which we'll call -2, 5. And then this point here, which we'll call 3, 1. And we have to choose which one's going to be point 1 and which one's going to be point 2. I'll just call this one point 1. And we'll call this one point 2. Again, it doesn't matter which one's which. So y2 is going to be 1 minus y1, which is 5. And then x2 is 3 minus x1, which is -2. And so we get 1 minus 5 over 3 plus 2, so -4/5, which is exactly what we got visually. And so what we can do, even if we don't have a visual, using just that formula, we can figure out the slope, even if we don't want to take the time out to graph it. So here's a problem here. So if we want to find the slope using 2 points, this one and this one, so the only thing we need to do, we don't have to graph it, we just have to decide which one's going to be point 1 and which one's going to be point 2, so I labeled them that way. So y2 is going to be -4 minus y1, which is 2, And then we have x2, which is 3, minus x1, which is negative 1. Negative 4 minus 2, and 3 minus negative 1 is 4. So the slope of a line that contains these 2 points would just be negative 3 over 2. The last thing that I'm going to talk about here is slopes of horizontal and vertical lines. Again, we can use the formula that we've been given here. So let me copy this. Oops. Alright. And let's paste that form. Oops, not that. There we go. So here's the formula. And we can use it to find the slope of a horizontal and a vertical line. So let's start with this one, the horizontal. And we can pick any 2 points here. Any 2 points at all. Let's keep them positive and make it easy. So we'll choose 2, 4 and 5, 4. And we call this point 1 and this point 2. So y2 is 4, minus y1 is also 4, and then x2 is 5, and then x1 is 2. And so the slope is 0 over 3, and so the slope of this horizontal line, and every horizontal line, is going to be 0. Over here we have a vertical line, and we'll pick 2 points. How about negative 4, 3, and we'll pick negative 4, 6. And we'll call this point 1 and this one point 2. So y2 is going to be 3 minus y1 over x2 minus x1. And in this case, negative 4 plus 4 is 0. In this case, we're dividing by 0, which is undefined. Therefore, the slope of a vertical line is also undefined. So, the slope of a horizontal line is 0. The slope of a vertical line is undefined. And that's it for this video. Thanks for watching.